Okay, welcome everyone. Thank you for joining us, me and Suzanne, for the Simulations and Gamification in the 21st Century Classrooms webinar. We actually have been promoting it for 2 weeks, more than 2 weeks now, and I've been spreading the word and I've been talking all about it. And if you have been to my nonsense, I would say, I'm pretty sure you were like, now, okay, let's watch what it is. All right. So I have with me someone very special, and it is Suzanne Saraya. She's Director International for an American-based ed tech company, Explore Learning. Explore Learning is a company I have been following for a very, very long time. And I was fortunate to meet Suzanne directly at the STEM MENA conference this year. And I must say, this lady will actually win your hearts because she's not just knowledgeable about what she's going to talk about and what she promotes, but she is a really, really nice human being, a very wonderful person to talk to and to listen to. Okay, Suzanne, I won't take more time in introducing you. I would like you to take over and talk about yourself, your company, and what you are going to actually teach us today.
Thank you so much, Wajiha. I think the feeling is mutual. It was a wonderful opportunity to meet you at STEMina. We'll talk about STEMina in a bit. I think it's everybody's gonna have to listen and hear what we've been doing in terms of STEM in the Middle East, where we're really innovating in many ways. So, just a few words about myself. My name is Suzanne Sarayas. Wajiha has introduced me, and I am an educator by nature, but my background actually comes from science, from astrophysics. That's what I studied, that's what I was passionate about. And as I had an opportunity to travel throughout my youth and as well throughout my job and lived in many places around the world, it really gave me an opportunity to want to give back and find an opportunity like this one to share with you a little bit what we've learned from STEM and how we can really support our students and make them future ready, allowing our students to really succeed and be open to all of the opportunities that this world can provide them. So, today we're going to talk a little bit about this fantastic topic that is gamification and simulation and how it can support those 21st century necessary skills with Ms. Wajiha. And thank you so much for inviting me. I really appreciate this. And thank you all for being here today and listening to our conversation. I hope you'll participate, come in and give us your opinion. There's nothing better than hearing feedback and ideas from everyone. So the topic of gamification and the idea of simulation comes from the fact that we're in a really interesting world, right? Like if you think about your students, really our learners today are what we call digital natives. They grew up with digital technologies and they have different learning styles and even new attitudes to the learning process. And actually, I find that they have higher requirements for teaching and learning than ever before. So teachers like us have to use different methodologies and approaches to really allow these students to be more active participants in this process and really to have much stronger motivation. And that's kind of where we came up with at Explore Learning. That's how we started at Explore Learning. We wanted to find new ways to reach these students and truly give them all the opportunity to succeed, particularly in STEM, in mathematics and in science. And I believe the topic of gamification works extremely well in here, and really the idea of how we can help our students be more excited, more engaged, and have more student agency, more in charge of their own learning, rather than just sitting and receiving learning, be active participant in that learning. And that's where the idea of Explore Learning came, how we can facilitate the students' learning approaches and allow everyone, no matter what their background is, no matter what their abilities is, to actually succeed at math and science. So that's kind of the philosophy behind it, and finding ways that are innovative to do so.
Okay,
So that's how we
Suzanne,
started Wajia.
Suzanne, I mean, I was just thinking about two things right now when you were talking. Number one, the name Explore Learning. I mean, it's
Yes.
it's it just clicked to me right now. Explore learning.
Exactly. That's
What
it.
was the thought process behind like actually naming it Explore Learning, and what led to it? What was the vision behind it?
Well, that's exactly it. I mean, we started with other names as we began in 1999, so it's been a while. But the idea of Explore Learning came from, yeah, it's been a while we started. So this is way before technology and edtech was it. Like we are the leaders, we're pioneers in that area. And what was really interesting with the idea of Explore Learning is it came naturally. So, same thing as the name of some of our program, the one that most people have heard of might have been or might have heard of is called Gizmos. It's something that we started talking about. Oh, when we were creating the simulations called Gizmos, we're like, oh, those gizmos, and the name stuck. But Explore Learning really reflects what we want. I think learning is an exploration, a never ending exploration, a lifelong exploration of the world around us. And what better way to explain that than through a name like Explore Learning? We want students to understand like us teachers, we're explorers in many ways. We're always looking for new ways to help our students. Well, I think that that's what we want from our learners as well. We want them to become those explorers of whatever topic they're interested in, listen to their passion and develop them. Because if you develop those passions, you're really going to succeed in your life, no matter what. At least, maybe not always in the way you imagine success, but at least a personal internal success. If you're always doing what makes you happy and what feeds your passion. So, gamification, we go back to gamification. Gamification is part of this. It's not a new concept. I mean, we've been talking about gamifications for many years, and there's been, interestingly enough, a lot of research. So let's define a little bit that term. We talk about gamification. What is it? Well, gamification is defined as using what we call game-based mechanics, aesthetics, and game thinking to engage those students and motivate them so they can have a more of an active learning, so they can solve problems. And what we do is that we integrate game element systems like, point systems or interactivity or immersive solutions just to create a fun learning experience. Learning doesn't have to be boring or punitive. It has to be, at the contrary, something pleasurable and something that allows you as an learner to enjoy the process and not struggle with the process. That doesn't mean that every time you're going to learn it's going to be fun. There's certain things we have no choice, we have to learn them. But gamification allows this to become much easier to do. So it allows students, for example, to be um, able to do goal setting. Oh, I want to reach this level in the game because we're using games, right? It's going to enhance the learning experience, as I said, and make it more interactive, but also allow them to gain depth of understanding and mastering of material. What it's also going to do is, particularly the research has shown in adolescents, it aids in their cognitive development. So this is all research based. It's not me saying it. This is lots and lots of researchers. I mean, we can give you pages of research documents on this. And it increases, of course, for your teacher, the level of engagement. But also, interestingly enough, it reduces anxiety. So having less anxiety in the classroom is very important. Another piece that I think is exciting when you're doing game based learning is that you can offer more personalized and adaptive learning. So when we're teaching in a class, it's always we're teaching to the whole class, and sometimes we do small groups and we work with those. But there are certain areas of teaching that's very hard to do on a continual basis. You can do small groups in one area and small groups in this topic, but to have that continuous adaptive learning happening, technology and game-based learning is really going to facilitate that, because the system automatically will figure out where you are in your learning and adapt itself and adapt the games to where you are in your own level. But I have to say one thing that is really important to me. For game-based learning to be effective, it has to be accompanied by traditional classroom instruction. You can't just put a student on a game and hope for the best. You have to be able to accompany that, and that's research again, with traditional classroom instruction in which you are teaching the classroom, and these games become, or this gamified learning becomes a way for you to improve, enhance, and deepen the learning that the students are doing.
Okay, so I mean, I think this is something that I really like what you just stated,
Mm.
that gamification cannot be a stand-alone thing. Like
Yeah,
for teachers, they must realize that first of all, the traditional teacher-led or teacher-centric classrooms matter,
yeah,
and then from there you transition into like using gizmos or fracs or whatever explore
yeah,
learning tools you have as supplementary tools. Isn't that what?
exactly.
Yeah.
That's absolutely it. And there's a little thing that you have to think about, that not all technology is equal. So there's a recent research piece that came out not a long time ago on a platform called Learn Platform. And what the report was that 26% of the top 100 most used edtechs meet high quality research standards, but only 26%. So when you think about finding the right technology, it does seem a bit daunting, but you have to think about what is the research that each of these platforms are offering, and we want to make sure that they're pedagogically sound. We don't want to put our students on games that may, for example, have mistakes in them and we're teaching math, or mistakes in them if you're teaching science or English learning or whatever it is that you're teaching. So it's very important that we think that although gamification is absolutely the way of the future, it, the way that we learn, our students learn today, we learn ourselves for the most part. We're used to technology, especially after the period that we've passed through COVID, where we've all been on technology. So I want you just to think that when you're using technology, be very critical of it. Look at it and think, what is it being, based on? What is the content? Has anybody done research? Are there any study cases? So in our case, for Explore Learning, everything we do is heavily research based. So let me introduce you a little bit Explore Learning. As I said, Explore Learning, we started in 1999. It was started by two teachers, a math and a science teacher. And the idea behind it was really to think about how we can help students succeed at the highest level. Because if you talk to teachers at the universities, they all complain, oh, our students aren't always of the proper level because they don't do what needs to be done in high school. In high school, they say, oh, students, they're not as great as we would like them to be because they're not starting earlier in middle school, and middle school will blame elementary. In reality, what happened is it's more an approach to teaching and learning that has to combine critical thinking, that has to combine communication skills, collaboration, and particularly creativity. Sometimes in math and science, we think creativity. Why? Absolutely essential part of science and math and STEM overall is creativity. So, how can you combine all of those? How can you, every time you have a lesson in the classroom, hit on all of these different areas, right? So that's why it's so important to have programs that are well vetted, well researched, that understand the needs of the student, understand how the brain functions. How do we learn? If we don't base our programs on how the brain functions and how the brain learns, you're not going to be able to have a program that's effective. And it has to be followed up or shouldered by case studies. So we might not produce hundreds of programs every year. We produced 4 programs since 1999, Gizmos being the platform that is the most important. We'll talk about it in a second. Then we came in with Reflex Math, and Reflex Math is the program that is out there that is extremely, like, that's the personification of gamification. It started off, as I said, years ago with the idea of supporting students with their math fluency, their understanding and control of all of the math facts in mathematics, addition, subtraction, multiplication, division, which are fundamental to everything in mathematics, the alphabet of math, right? And so, if we are able to support those students there effectively, but in an adaptive way, and getting a lot of reporting back to the teacher, then our students are going to be very successful because then we know, I don't have to tell you, I think all of those who are in attendance today have heard that study after study has shown that really you have to have a proper automaticity for students for long-term success in mathematics. Actually, automaticity is a predictor of performance on general math tests everywhere.
Okay, I'm just
And
going to then take two
yeah,
minutes and translate, like, or summarize whatever you are saying to the
yes,
audience
go
here.
ahead.
Okay, so basically, Suzanne was, I'm such a bad flow of using English. Okay, तो इस वक्त जो है सुजैन जो बात कर रही थी वो गेमिफिकेशन के ऊपर बात कर रही थी, एंड सबसे इसेंशियल पॉइंट ये है कि एक्सप्लोर लर्निंग जो है वो रिसर्च बेस्ड सॉल्यूशंस डेवलप करता है 1999 से. गिज़मोज जो मुझे सबसे ज़्यादा लाइक पसंद आता है, या गिज़मोज वाज वन ऑफ माय फर्स्ट कनेक्शंस विद एक्सप्लोर लर्निंग. वो एक बहुत ही वेल रिसर्च्ड प्रोग्राम है. इट वाज नॉट क्रिएटेड ऑन अ विमेन फैंसी. और हर चीज़ जो है, जब आप गेमिफिकेशन भी इम्प्लीमेंट करते हैं अपनी क्लासरूम में, तो इट हैज़ टू बी लाइक फ्रॉम यू, आपसे उसको ट्रांसफर करना चाहिए टुवर्ड्स योर स्टूडेंट. ठीक है. सो नाउ I'm going to let Suzanne take over.
Yeah.
Okay. Yeah.
So thank you, Wajiha. So as I was saying, like we have to think about as well um, that. So in overall, I'm gonna kind of go back to what we said. Research is important. Gamification and research. That means even gamified programs have to be heavily researched. And one of the examples, we have two examples for gamified programs within Explore Learning. Reflex, that takes advantage of the latest math fact fluency research and has this adaptive, individualized system. It continuously is going to monitor each student's program and create learning experiences for each child. And what's great about Reflex, because we believe so much in its ability and what it can do, and we know that we have lots of research on not just how we created the program, but the effects of the program. That we actually every year offer grants for teachers. So if teachers want to try the program for a whole year for free, they can come in and let's say if they come in now, they'll get until July. So usually we offer it between let's say August and July every year. So if you come in August, you'll have access to it. You apply, you'll have access to it until July of next year for free. But you have to apply. You have to, follow certain requirements. Some of the requirement is proper use because we don't want to give you a grant and not have you use it. So we require with Reflex for it to be effective. Listen to this: 2 to 3 times a week, 15 to 20 minutes. That's it. And I can tell you that in 3 months you can change someone's life. Why I
Okay, let
like
me
it?
say
Yeah,
that
go
was the
ahead.
most essential part.
Go ahead. Do you
Okay.
want to repeat? Yeah.
Yeah, I'll just translate that. So basically, सुजैन ने ये कहा कि एक्सप्लोर लर्निंग जो है वो ग्रांट्स प्रोवाइड करता है टीचर्स के लिए, स्कूल्स के लिए, जो उनके प्रोग्राम्स यूज़ करना चाहते हैं, लेकिन उसके कुछ कंडीशंस हैं. आप जो है वो ईयर लॉन्ग ग्रांट के लिए अप्लाई कर सकते हैं, लेकिन वन ऑफ द फर्स्ट कंडीशंस इज कि आप हफ्ते में 2 से 3 दफ़ा, 2 to 3 times इन अ वीक, 20 मिनट, 20 मिनट्स के लिए उस प्रोग्राम को इम्प्लीमेंट करेंगे टू बी एलिजिबल फॉर द ग्रांट. ठीक है. ग्रांट एप्लीकेशन के लिए. नाउ आप किस तरह से ग्रांट अप्लाई कर सकते हैं? सुजैन, आई थिंक अप्लाइंग फॉर द ग्रांट दे कैन आइदर कनेक्ट डायरेक्टली विद यू और थ्रू द
Yes.
वेबसाइट.
Yeah, we have it. We'll have it open on our website in August this year. But if you're interested, just reach out and we can help you otherwise. The other thing we do is that with, just so you know, with the one of the things that we're going to be requiring you is feedback, because again, we're lifelong learners, just as you, just as your students. So when you look at how the program was years ago, we've always added new features. So the grants that we offer are help us get your feedback and real responses from the classroom, so then we can adapt and add. So for example, part of gamification, because the whole thing is a game, you can earn points, you can have an avatar, you can truly build your own like area where you purchase items for your avatar, and all of that is the fun part, the gamified part. The biggest problems you'll have with Reflex is you can't get your students to get off of it, right? Like that's our bigger problem. And I can tell from a parent's perspective. I had a child that was struggling with math, and she was on the program for 3 months. It changed her life. After 3 months, I can tell you that she is now years later doing math at the highest level. She's the most advanced classes of mathematics from a child that came that hated math. And that's the other beauty of reflex math is it changes. That's what gamification does. It changes the mindset around math. So that's really important when you think about gamification. Good gamified programs change students' mindset and move them from a fixed mindset, being able thinking I cannot do math, to I love math. And I've heard that, I've seen that personally hundreds upon hundreds of times. So if you'd like to get access to that grant, we're happy to help you. And if you come from, let's say, areas where maybe you don't have as many opportunities, your chances of getting the grants are actually higher than, let's say, an area that is, we want to really support those schools that don't have opportunities like these. Um, and across the world, we have schools in over 80 countries that use our programs. So we know that it works and it works very well. So grants for reflex, and guess what? There's another program that you can get grants for. It's called FraxMath. Also another gamified program that we have that came out after reflex, but this one functions and focuses on fractions. Fraction learning has not really, or fraction success has not been there in education for many years. If you look at research over the last 50 years, students still struggle with the same thing they struggled with 50 years ago. So Frax Math was built on the latest research, and I can share that with you about how we teach should be teaching fractions, and we offer grants of that program as well. So it's really helpful, and I know you want to share that with your audience. It's really helpful to know about this.
Okay, so just translating that, द ग्रांट जो ग्रांट्स हैं वो स्पेशली उन रीजन्स के लिए जैसे पाकिस्तान है, इंडिया है, श्रीलंका है, बांग्लादेश है, जहाँ पे लाइक टेक्नोलॉजी एक्सेस या फाइनेंशियल रिस्ट्रिक्शंस हैं, private schools are not functioning like they should be. Those countries are actually more eligible for the grants, provided कि आप उसको सही से इस्तेमाल करें. So I know a lot of my audience is from Pakistan on Facebook as well as on LinkedIn. A lot of people watching on YouTube also. Please connect with Suzanne, connect with Cynthia also. You can apply directly through the website. Yeah,
Thank you,
Suzanne.
thank you. So that's how we try to give back, but in the same time, as I said, everything is a give and take. We get to hear from you. We get to hear your feedback, and we integrate what you've give us into our program to make them better. That's how we continuously improve our programs. Now, I have to tell you, when you come to us with particularly those two programs, we'll talk about gizmos in just a second. What we can also give you is all the research we've done post production. That means when it's being used in large numbers of schools, how it has improved learning. For example, how many of you have heard of NWEA MAP tests? Right? So we know that we want to improve NWEA MAP test results. I'm sure you've heard of them and your audience have, right? We have a study, a 2-year longitudinal study with reflex math that shows you how just using reflex math improves the test results for map testing. So the lowest level after 2 years is increased by more than 20 percentile. So they move from the lowest level to the next level up, and so on and so forth. So if you're really trying to improve map test results, I always say that's my magic bullet. Reflex math is my magic bullet. It's so easy to implement, and I know why it works. It works because it takes into consideration how the brain functions. So when you learn, like today, I gave you my name. I said, my name is Suzanne. Will you remember it tomorrow? Maybe, maybe not. So it all depends on how your what we call working memory functions and your long-term memory. So this is how our brain functions. Every time we give it information, it takes it on in this part of your brain called the working memory. And then depending on how, maybe you've heard me a couple of times, maybe you've done another one of our webinars. Maybe you're going to do something on a regular basis. You're going to remember me. It's going to be easy for you to remember me when you see me and remember my name. That means you move that information into your long-term memory. And that is one of the process of math fact fluency. I'm simplifying it. Our webinar is much more explicit than that, but just to give you an idea of brain research added to gamification, added to platform research, that's when you end up with programs like Frax and Reflex.
Okay, so Suzanne, I think the audience is getting a little eager to see what it really
Okay.
is.
All right, let's do this. Well, I want to talk a little bit very quickly about what we're going to start with. We're going to start with talking about a program called Gizmos that we mentioned in the beginning. I think that's really important, and that is a program that I'm going to share with you called. Right now I'm going to share with you that is called simulation. And what simulations are, everybody knows, they're instructional models that demonstrate a process or a situation where you can really manipulate the key variables, test hypotheses, and really engage in extensive what if exploration and experimentation. So let's go look at them. I'm going to share my screen and hopefully you can see that. Let me see if
No,
it's going
this
to
is the
share it.
this is the exciting part. I'm really
Yes. So I'm going to take you to my screen here. I hope you can see it. Let me know if you can. And in this is where we have all of our programs. So we've talked about Frax and Reflex. And we'll talk about Science for Asset in a second. Let's talk about gizmos, which is what we call serious games. If you've ever heard of simulations, you've also heard of serious games. So let's go explore it. What is it? We have about 500 simulations that are housed in what we call gizmos. I'm just going to take me back to my account. I guess we've been out for a little too long. It doesn't like it. So let me go back. And what we are going to do in our Gizmos is we're going to cover all kinds of areas in both math and science. And I'll show you how it's set up. So when you log into your Gizmos account, and we have free accounts for everyone, what we will do is you can sign up and you can have a trial. It's free. You'll have access to all 500 simulations for the first 30 days. Here's my what your platform looks like, what my class looks like. And now I'm gonna explore gizmos. How do I explore them? I'm using this little tool up there, and I'm gonna either put a keyword or I'm gonna look by standards and grades. Let me just start by just showing you a keyword, and I'm gonna just do the word plants. As we're looking, remember these are STEM simulations, which means there's going to be a lot of math and science and design engineering, etc. I'm going to take the first simulation that comes out here that's called plants. I'm going to start something simple just to give you an idea of what it is. And what you can see when you log in is we've got this simulation here that we're going to jump into. And in here, what we have is a description of what we're going to do. We're going to do an investigation to grow 3 common garden plants. And you'll see you've got material here. We'll look at it in a second. Let's just launch the simulation and see where it takes us. And I'm just going to make it full screen so you can see it well. And this is what a simulation is. I have options, I have variables. I could run this through a simulation, through a real world. We've all done it, right? We put some plant in the closet. We put some plant on the windowsill in the classroom. But are students really able to quantify how much water they're putting every day? Do they forget? Do they remember? It's a great add on to a real life experiment. So what do? I can change my water, right? I can turn on and turn off lights, and I can choose what kind of material supplies I'm going to use. So let's say I want to talk about in my class, I'm like, I wonder what if more light or less light is needed. What is the effect of light on the height of a plant? If I want to grow a tall plant, how much light do I need to use? So I'm looking at my material here, and I might use some beans because I know beans tend to grow tall. So I'm going to easily, as you can see here, take my beans and put those in each one of these pots. And what's really important to think, and that's part of a good program, is this works on any one of your devices, your phone, any kind of a browser. It's written in a language called HTML5, making it very easy to anyone to access. So you don't have to worry, is my computer going to take it? You have access to the internet, you can use gizmos. So now, just to make it all the same, because the only thing I want to change is the quantity of light that I am exposing the plant to, I'm going to put some fertilizer and compost in all of them. And the only variable I'm going to change, as you can see here, is going to be the light. So in this one, I'm going to keep all my lights on in this first experiment A and keep the water at 15 milliliters. Here I'm going to turn off one light. As you can see, it's very easy for anyone. And here I'm going to turn off all the lights. Now, if you want to play along, because since we're talking about gamification, would you like to make a prediction? Could anyone predict which pot is going to have the plant that grows the tallest? So if you would like to put that in the comments, you can go in and just put in your what you think is going to be the plant that has the tallest A, B, C, or D. A is in full light, B is in with only two lights, C is in very low light, and D has no light. Now, when I do this with my students, they just all of them raise their hand. They say, nothing is going to grow in D because, well, without light, we can't grow anything. Okay, let's see. And now we run the simulations. As you can see, by the way, the way we built this, if you're interested, is we hired a lot of families, we had them grow these, and we collected all the data, and then we aggregated the data, and we put this data inside of these simulations. So as we start observing what's happening, we're going to give it 50 days. We can pause, as you can see, at any time and have discussions with our students, but we can continue running it. And then after 50 days, what do we notice? We see that plant B is the tallest. Could this be a mistake? Most students usually tell me that it's plant A that is going to be the tallest. So we can reset easily. See what I mean? Like, this is the beauty of simulation. It takes 2 seconds. I can do something in 50 days, right? So now I can get results and I can have this conversation, very rich conversation with my students. Why is something growing here? I would be a question I would may ask my students. And some of them will end up saying, yeah, because there's germination that happened, even though there's no light, right? We look at this spot here, like earlier, it didn't look very good, right? Like very few leaves, not very tall. This one seems again to be the tallest, slightly different results. Let me pause here and tell you something really important about a good simulation. Simulation, to be really true to life, to what's happening in the real world, have to have different results every time. Tendencies like these, of course, are going to be the same. It's not going to change the science. But if you were to plant every time a new seed, you wouldn't always get the same height from the plant. You wouldn't get the same size plant, height, weight, etc. So having those modifications and those changes are crucial when you're working with a simulation. And it's a big difference between an animation and a simulation. Because when you're changing the variables, things change, but also in this case, in the real world, our plants would not grow to be the same every time we put a new seed. So what's great about this is, of course, you can take individual pictures using this tool. We have one big tool here with, if I want to take a screenshot of the end results to include it in our work, we can see that again, we seem to have the plant in, medium light be the one that grew the tallest. But let's bring in some mathematics into all this. In this other screen, what I have is all the data that I collected, which is usually, important to have if you're going to analyze and do some work. So you can export it to Excel. You can take pictures again of it. You can look at the plant height in a bar graph or even a line graph. You can show some of those results right here. And now we're starting to bring in mathematic understanding with a science simulation like this one. We're bringing a connection between graphing and growth of a plant, something that the students can start understanding in reference, frame of reference, in order to continue developing their abilities in math as well. So as you can see here, we started very simple. This is a very simple experiment, but we can make it even simpler. We can change this experiment. And as you can see here, I've created multiple experiments. Like here's an experiment that I've created before, and I can save it, which means that when I come back, so if I were to reset everything, clear my pots, start from scratch, return on every light and say, okay, I'm now back in my classroom, I'm teaching, I want to show them the experiment in my class. Look what I can do. I can have a preset experiment and it'll reset my experiment to what I had created earlier or another form of an experiment that I've created. So as a teacher, I don't want to be fiddling with the variables in my class because I don't have usually hours with my students. So this is a fantastic way, not only for you to do the study with and do the work with your students, and even you can let them create their own experiments if they have access to it. But if you're in a whole class and you're just teaching by throwing this on the screen because maybe you don't have the technology, then all you need is a wireless mouse and you pass it along and students can make modifications and create their own experiments. To give you an idea, we can run over 300 experiments just with this particular simulation. You can make modification on the light, the quantity of light in the water, whether fertilizer is going to be better than fertilizer and compost. Fertilizer and compost, is it better for turnips, beans, tomatoes? The possibilities are endless. Now, for you as a teacher, you're thinking, well, that's a lot. I don't know where to go. Well, we've done all the work. We've done all of the lesson material. So when you open your teacher guide that's included in the material that we give you and you click on teacher guide, you open it and you'll see that we've got your lesson plan with the scope and sequence, everything for you to look at. What are we going to try to accomplish here? What is the lesson overview? And then we know that differentiation is important, right? We've got different students of different abilities. So whether you're doing differentiation, individualization, or personalization, depending on what you're working on, these are already differentiated by abilities, which means activity that we recommend is going to be the simplest activity. Here it is, student explore whether plant needs water to grow, right? Something very simple. Activity B, which is what we've done today, very quickly, we examine the amount of light for the plant growth. And activity C, this is where you do a lot of design engineering. We're going to push students to create their own questions, their own inquiry, and then design an experiment to answer it. So designing an experiment is engineering. You're going to do a lot of inquiry in there, and the students might say, "Well, I'm curious to know whether it's better to use fertilizer and compost, or just fertilizer, or just compost." Why? Because fertilizer, for example, is usually chemical fertilizers have some effects. There are runoffs and issues that can be caused. So how can we think about using? In what cases could we use just a compost, maybe? So those are questions that the student can ask and learn how to research and take it from there. So if you go to explorelearning.com and you choose or gizmos.explorelearning.com, you can have a free access to this and access 499 more simulations that go with it. So let me walk you through the teacher guide again. And this is the same teacher guide for every one of those simulations. We even have critical thinking questions already embedded in here. So as a teacher, if I have to start thinking, boy, what question am I going to ask here? It's going to be hard. It's going to be time consuming. You are so important in the classroom. We want to do the work for you. So we have all these questions already embedded. For me, I like to take them sometimes and from there jump to another question that maybe I'm asking or ask my students, what else would you like to find out? And look at this. One of the questions we asked you earlier is why do plants in dim light grow taller than plants in full light? And questions that are a little bit more complex, like are results from the same experiment always the same? Why or why not? How much data do you need to have results that can be trusted? So, a lot of important questions, but it's fun, right? Follow up activities for you, scientific backgrounds, and a real world connection. Why is a re- I don't know about you, but I know, Jia, you might have heard that too. How many times did your students say, Miss, why are we learning this? How am I going to ever use that in my life?
I
Have you
think
heard?
that is the most common thing teachers hear, and we are unable to link it. But real life
Mhm.
applications, I mean, I know that I have changed context in terms of
Yeah.
where I was teaching and learning like before and where I am now. So, real life applications here are very important.
So we have a real world connection always, so that the teacher can start with a real world connection as the background to the program, but also they can talk about, they can look at other resources. We've vetted resources online, and we've given you the links here. These are all free resources you can use to expand on the topic, and then look at this here. You've got all of these other gizmos that are going to relate. So this is your teacher guide. This is for you. For your students, because we are an open-ended, inquiry-based, focused company, we've created a model lesson following the 5E model so that you can actually have the students, and you can modify this. All these documents are in Word. You can change them, modify them any way you want. But you can see here how the student exploration is set up with prior knowledge questions, so an engaged question, right? And then you go into the question that you're going to do, the activities. These are not worksheets in the way you imagine our typical worksheet. These are inquiry questions. So, do seeds need water to grow? Is the first question. Remember that idea from activity A. Well, how do we answer that? How would we go around? We have to teach our students methodologies. We have to start going in there and explaining that first you have to form a hypothesis. Just I'm gonna have to pause. I see that Lisa Grace Wilson is.
Yes.
I have to give a shout out to one of my favorite people in the world, Lisa. Thank you for being here. We love to see you soon. Cannot wait to see you very soon.
Yes,
Hopefully,
Suzanne, I was just going to ask you to pause for a moment, and I
yes,
want to give all my love to Lisa, because
yes,
I think, yes, she's been instrumental in connecting us.
she
So Lisa,
is. She is.
because of you.
And she's one of the most also amazing people in the world. So I am very blessed in my life to know her, and anybody who I've been introduced to through Lisa has been a blessing as well. So thank you so much for being here, Lisa, and for being the awesome person that you are. I hope you're blushing because you deserve a lot more. So again, let's go back to our little student exploration sheet. As we said, one of the things we want to teach is not just content, but we want to make students able to learn how to come back in and really learn how to solve problems so that when they face unknown problems in the future, or unknown technology, or they have issues that they have not even learned about it in school, how do they approach it? They have to have a proper approach and method. So this methodology here is going to be taught to them through these exploration sheets. Form a hypothesis, set up your experiment, collect the data, draw your conclusion, revise and repeat. All of that we can do very easily, and we can modify it. So I like to add more questions, more challenges. Sometimes what I may do is I may even, depending on the type of inquiry I'm running, I might just remove some of these extra pieces and just let some of them figure out how they're going to do it by themselves. For others, I may do something like more of a confirmation inquiry, which I will put the answers through. So I will work with the answers through them. So there's a lot you can do here. We could possibly spend 3 hours just talking about how to develop an inquiry and what type of inquiry you want to run and why. But as you can see, as you move through, you'll have those more complex activities with more to think and more challenges, because we want to challenge our students. They're going to be challenges within it. So that's the student exploration sheet, which if you sign up, you'll also have access to, no problem. And you'll even have a vocabulary sheet. You'll notice here when I click on it, you'll even see it like in French and Spanish. So you have sometimes different format, and even in a Google Doc. So if you're a Google school and you just want to do the whole thing in Google, you can do that as well. Finally, there's the vocabulary sheet. That is the most important vocabulary that we're going to be using with definition. And if you scroll lower, we've even collected lots of different documents that you can use. For example, a mini virtual science fair activity, a take-home test activity, all kinds of additional material that you can use, a STEM activity in that particular simulation. So as I said, like this, we have about over 500. So this is an example of a simulation. How do I find these simulations? I can just browse by, let's start by grade and topic. So depending on where you are in the world, you may have different categories, but overall you have math and science. And then the grades go from 3 to 12, and you have the different topics in both math and science. And so if you are interested in physics in grade 9 to 12, you would log in and you would look and see here the subtopics, etc. The other thing that you may have is look at it from an academic standard. So you may have the different curricula. So if you're in the US, these are curricula. If you're in the UK, you're following UK curriculum. You can click and see the alignment, let's say for Key Stage 2, exactly the same way, etc., etc. If you are in following an IB curriculum, you can definitely if you're using an IB curriculum, we can give you access to that as well, etc., etc. Now, another thing that's really fantastic is to look at books. So if you're following a particular books, let's say you're using a Pearson book, and you want to see what's been offered within Pearson. So what you will see is you will have here in my list of books, let's say you're using Elevate Science Grade 4, and then you see the book and you see the gizmos that are aligned to that book, so that you can always have a book that you can relate to based on what you're working on. So if you don't have, for example, a book that you don't find the book here, we can add it. You just have to ask us. So really many ways for you to find these simulations. I want to pause. I know you were in and out of the session, probably internet issues, which we all deal with all the time. Any questions so far you want me to answer?
Okay, so what I actually had, not an internet issue, but a
Oh,
browser issue. So sort of landed
okay.
out. Okay, so I mean, it's not a question, but it's like, I mean, you are giving the world to
Mm.
the teachers on
Yes,
a plate, and you're
yes.
telling teachers to, oh, come, like, take it for free from us. Uh,
For the first 30 days, we of course there are
for the first 30
subscription.
days, right?
Yes.
And then, but
Yeah.
you're also providing, and I'm just repeating this because there's some people who have just joined us, and you're also
Yes.
providing grants for
Yes.
countries that like have difficulty in accommodating or like affording this type of thing, right?
Yeah, for reflex and frax, for our gamified functions
Yeah.
of yeah. And for gizmos, we have different ways. We have extended access to help you so that you can see. We have special pricing as well. So when you're working with countries that have like don't have the same economic models as, let's say, we have in Canada, the US, uh, Australia, etc., we have our special models as well to support you. And I have to say that one of the ways that we have, I'm going to go back to show you another simulations while we're doing this. One of the ways that we have really supported these schools as well is because we know at the end we want them to learn, is we launched a few years ago with the help of Teach Middle East a competition called um, Gizmo STEM competition, team projects competition. So it started off just in the Middle East, and now it's a worldwide competition. It's a global competition. So what we're asking students to do in schools around the world, particularly we're going to relaunch in the Middle East for next year and coming up any day now. What we offer is an opportunity for teachers and their students to create a team of students that are going to explore a concept or a project in STEM project. Like, for example, they're going to say, well, I want to figure out what it takes for to maximize energy in this building. So they're going to use simulations to learn the concepts about, you know, um, energy and energy conservation. And they may then build, let's say, decide to build any kind of machine that, or look at how they're going to minimize, how they're going to set up a program to minimize energy in their own building. So that's a STEM project. And what is great about it is that you can participate in this competition as a student team, and we can give you all that information as well. We'll give you a link to our global competition page, which is now done for this year, but we're at the ends, we're at the finals right now, but we're going to relaunch it for next year. And so those students are able to participate. So what we did with the Teach Middle East and STEM MENA is STEM MENA was actually created with the idea that we needed something more than a regular conference. We needed a conference that was very much focused on actionable, at learning, something that you can take from the conference and use right away in the classroom, not pie in the sky. and really learning about what really works in STEM. So that's how Stamina was created. What we added to it on our end is our competition. So when you come to Stamina, you will get the finalists from the Middle East region that come in, and those are those teams that have submitted and have been chosen to come to the semifinals, if you'd like. And we choose the finalists during at the end of the competition. So you get to see all the project and you get to be inspired by students. And we've done this now twice, and we're going to our third year with that. And those students, when they are chosen, they get to go become finalists in the global competition, where students from all other regions in the world are gonna also be finalists, and then we'll have that global competition coming up this year. In the spring 2024, we'll name our first global champions. So those are students that are going to be showcasing very unique projects when it comes to STEM. I have to say the STEM competition this year in Middle East was amazing. I was so inspired. I was so inspired by the students and what they've been able to come up with.
Okay, so for the audience here, I'm pretty sure Lisa has been one of the is the mind, thought, everything behind STEM Mina, and Explore Learning facilitates, and the STEM awards for students in schools are through Explore Learning at STEM Mina. I'm sure they're willing to accommodate you as well if you're from other regions close to the
Yes.
Middle East.
Yes, what we do is because we know that not everyone can attend live at the competition itself or at Stamina, we have a virtual strand that goes with it. So if you happen to be in an area of the world that you want to participate in and you can't be, let's say, go to the Middle East to participate in, well, then that's okay. You can submit online like many others around the world, and if you are chosen, then you go to the finals anyways, right? So the if you happen to be in the Middle East and you want to participate, we will have a live event for next year. We'll have a live event so that you can qualify to go to Stamina in Dubai and one in Qatar. and, and then you can choose whether you want to go to the live event or submit virtually. Both of those will be uh, work together, and then the finals will be named to go to the seminar in November. And then your team is invited to come and attend and showcase the work that you have done. We'll be giving you, stay tuned, we'll be announcing all kinds of information. I can tell you that the topic this year is going to be the SDG. So you have to choose an SDG topic and build your STEM project around it as a solution around it. And the anchor for your project, the learning or the what you're going to use are STEM gizmos. And using these gizmos to learn the content or to research the content and then build your STEM project. And so if you're doing the competition with us, guess what? As soon as you sign up with us, we'll give you access to gizmos for free to participate in the STEM competition.
Okay,
As
I
long
must
as
add
you're
here,
winning, you continue getting access.
and I must add here for like teachers in Pakistan, come on, you're just 2 hours away from
Yes,
Dubai and Qatar. Come on,
it's
get
not so
excited.
far. It's not so
Get
far,
excited.
and I have to tell you, last year or in when we met, you saw that the commercial attaché from the U.S. Embassy was there handing out the awards for the students. So it's really great way to expose your students and your school worldwide. Now we're gonna have. He promised to get us the ambassador next time, so hopefully you'll get to meet. If you're a winner, you get to have the ambassador hand you your prizes or your student prizes. So really stay tuned. We're going to be announcing a lot more around this. If you sign up for a free trial on the link that my colleague Cynthia has put in there, you'll get all the information automatically. And you get 30 days of product for free right now. And if you're interested in a grant, just reach out to us, and we will definitely arrange for you to have a grant if we can give it to you. We'll have to talk, of course, make sure that it fits what your school's needs and your classroom needs are. So, would you like to see another simulation? Just to give you another example, I have to
Oh,
tell you, I have two things I would like to show you. One, we're going to do one in math, And then I'm going to show you something unique called a STEM case. So if you're looking on my screen, here's an example of a math simulation. This one, it's all about understanding graphs. As I said, there's a lot of choice. I like this one because very often in mathematics, students that cannot read a graph are very blocked, much blocked from moving further, and especially if you move into higher level. Here, I'm going to show you the power of a simulation, how to interpret a graph, right? I have a runner here, and I have a graph already created. As you can see here, my runner is going to run from 0 to 40 meters, and how he runs it is described here by this line. How do you think, and this is what I would ask my students, how do you think my runner is running it? So having done that millions of times in classrooms everywhere, I've had teach students tell me, well, look at this graph. It looks like he's climbing a mountain. Or look at this graph. I think he's accelerating. So misunderstanding and misconceptions are very common in mathematics. And so we want to remove those, but we don't want to say you're wrong. We want to say, well, let's explore it. That's the methodology that allows students to explore what their hypothesis is, look at the data, come back, correct, self correct, and learn. So here's how we're going to run it. And now we're observing our runner. And I have this nifty tool here, that green bar, that allows me to replay that experiment. So as we can see here, he was at the 0 meter line, right? He was right here, and he hadn't moved. And 1 second passes. Where do you think he is now? So students can really observe and see, oh, 1 second, oh, he's at the 10-meter line, because this helps me read it. Oh, 2 seconds, how many more meters has he traversed? Oh, another 10 meters. Okay, he's at 20-meter line now. And another second, and another 10 meter, and another second, another 10 meters. Easy for me to say, so what do you think is his speed? He's at 10 meters per second, and it's constant speed. He's not accelerating. Now, the beauty of simulations, here's the beauty. I can modify my graph. I can do something like this. I can play around with the graph, and I can say, okay, what do you think is he doing now? It just took me 2 seconds. I didn't have to draw. I didn't have to do anything. Right then and there, 2 seconds now, I have another graph. What do you think he's doing now? And so we can allow students to start exploring, creating different graphs, for the teacher create different graphs, and to really start understanding the basics of what we call rate of change over time. So instead of starting by OY equals MX plus B, where M is the slope, which sometimes students don't always get, this is a great way to start. And how far can we take this? Well, we can have 2 runners. And of course, I remember how I had my presets earlier. So I can have different presets, and I can say, okay, let's do something simple like this, where, for example, we're representing a story here. This is the story of the hare and the tortoise. So if I were looking at my screen, if we know the story of the hare and the tortoise, I hope you all know the story of the hare and the tortoise. Which one is the hare? Which one is the tortoise in here? If we remember the story, what happened to the hare? The hare thinks he's very fast. He starts running much faster than the tortoise. Then thinks, oh my God, I'm going to win no matter what. So he stops and rests. And then he wakes up and he realizes that the tortoise has passed him, right? Now he has to run much faster to reach, but it's too late. So we can see it here, where the hare has done this graph and the tortoise has run a constant speed and reached the line way before our hare. So this is another way for you to start explaining and connecting histories and stories into a graph. So bringing a story into your mathematical activities is really interesting. And it's a great way for them to keep it simple. Now you can make it very complex. You can even go to like graphs like this, right? Where we can start calculating. And I've created that earlier, so I saved it. And then we can say, see, you can have y-intersect is here. You have different speeds across this particular race. And the story could be that we have two runners racing somewhere. You can decide where in your story, and then they can see what happens. Now, all of this is great for them to start exploring. But again, remember what I said, we have all of these lesson materials that are available to you in this exact same way, with a teacher guide that gives you all of the activities and the all of the questions. Like, let me show you, if we open it very quickly, like all of the critical thinking questions that we were talking about, scaffolded activities from A to B to C, or you can create your own. Remember, a way to get into the topic, an introduction into the topic, using the activities, and then these discussion questions, right? These critical thinking question, and then connecting it to a real world application, like talking about a runner name. I think everybody knows Usain Bolt, the lightning bolt from Jamaica, who's one of the fastest runners in the world. And so having that connection to start off with, and then connecting it back to graphing and understanding all of that, those concepts in a much more fun way. And how do I know if my students have learned? How do I know if my students got the concept and which area they're in? Right after each one of these simulations, I haven't shown you this yet, there are assessment questions. So I can get my students to answer them, and I can look in my classes and my results and see how my students did. So if I want to see if they did well on the particular questions, for example, I had some students answer here. I can see the results, and I can see that somebody here answered and he got three questions right and three questions wrong, and two questions right. So when I'm looking at it throughout my whole class, I can start figuring out where I need to intervene as well. So that if I see that most of my class didn't get question one, I may go back and work with question one. And you can see the question here. If you click on it, you'll be able to see it. And then if I want to see, well, and I want to print the results and then the scores, and then come back and reset it, so that after I taught my concept, I can go back and retest my students. That is doable. Now, it's not, we don't have a lot of difference. If you look at the simulation itself and we launch it and you see the questions here, they're not always going to be in the same order. So today, maybe question one is this. Tomorrow, question one might be this one. So it changes the order so that students don't learn 1A, 2B, 3C, like how students sometimes do. We want them to really think about it. And look at this. This is the part as a teacher that is I love. Not only does it tell you what the right answer is, but it tells you why, so that students can actually learn while they're actually doing assessment, and it helps you in supporting your class. So when you think about it, you've got simulations to keep them excited, control and agency for them to learn, differentiated activities, challenging questions for when we need it. You can simplify the simulation to help those students that may struggle. You can help with English language learners because, there's a visual connection and a bridge between what they know and English language. And there's inquiry, critical thinking, collaboration on different questions that you can have in activities. So really an ideal program, at least from the standpoint of a scientist, for me, to really support those students and an assessment to see where I need to intervene. Any questions?
Okay, so I mean, people are interested and they want to know if it would be available later for view as well. Yes, it will be. That's why I've connected it to my YouTube channel and my Facebook channel as well, so you can just access it from there. Suzanne, I remember when we were talking earlier before we were going live, there was something about language integration, like for people whose first language is not English. So, I mean, which
Let
one
me
was
show you.
yeah,
That
yeah,
one
yeah.
is for science for us. I'll show it to you in a second. Let me show you how we go to science for us. So what gizmos are, just to show you why gizmos are, really start at grade 3, because as you can see, students have to learn, be able to read, and work with the questions and the exploration sheets. It I have lots of teachers who use it in kindergarten, grade 1, grade 2, as a whole class or small groups, because they can read the questions and work with the students. But what we know is that in kindergarten, grade one, and grade two, in the early years, students have a different way of learning because in K to 2 or K to 3, you're learning to read. And in grades 3 to 6 or up, you're reading to learn, right? So what we have created for the early years is Science for Us. So this is a program again that follows that 5E model, and it is very much focused on connecting not only just science, but connecting science, math, and English literacy in the same time. So what we do in this program, and you can have also access to all of these programs for free for 30 days, anytime you get started and connected like I am, and just jumping from one program to the other like I am. Um, we start with a science concept. So we have four main, if you want, branches: inquiry, physical science, life sciences, and earth and space. Since we did a plant earlier, let's keep with the concept. Under life sciences, you'll have these subtopics. Let's say we want to do plants, right? And now, once you hit each one of these, and there are 28 of these different topics overall, you'll see that you'll have exactly a 5E model where you're going to engage the student in these activities, explore, explain, introduce the literacy skills of the science related to the science concept, then introduce literacy and the art for that concept, then go into a STEM skill in investigation and evaluation. But this is a blended program. Why? Because at Explore Learning, the priority for us is purposeful technology. I like to repeat that: purposeful technology. There's a lot of technology out there that is not. So when we have our students online, it has to have a reason and a meaning. It has to fulfill a particular goal. Online for online is not good. So, what we have in those early years where we want them to be online, we want them to learn, but not too much. So, it's a few minutes through the online pieces, and there is a counterpart for each one of these pieces offline. So you can download these and have an activity. Let's say we're doing prior knowledge around these topics, and the language we use are tier two and tier three words. So you'll see very strong vocabulary that's going to be used. And exposure research that has shown that exposure to this vocabulary early on doesn't mean they're going to know right away what photosynthesis is, but exposure to the vocabulary is really important for when they reach the higher levels because they'll have seen it before. So then you can spiral your learning and your teaching. So if you click on, let's say, prior knowledge for the students for grade one, you'll have activities that relate to that specifically. And then again, even here, we're very, very specific. When you open it, we'll give it a second to open. It'll tell you what our objective is, how long it's going to take you to run the activity, what materials, and all the materials we use in this program are either provided or something you would find anywhere around your house or around your school. You don't need to buy expensive kits and robotic to do STEM. If you're trying to develop STEM skills, if you can, that's fantastic. But I know many schools where I've been across the world, even in Canada, where in order for them to have internet working, they have to keep the classroom door open, or they have one projector in the teacher's laptop. So, does that mean we don't do STEM? Absolutely not. This is a great way for you to use it as a whole class. And you can do a lot of accommodations, and then you've got the material. We're talking about languages. So we use a lot of vocabulary here in this program. And as soon as we understand and we're in control of the science piece, we then bring in literacy and the arts. But we need to connect this to students' background knowledge. So if you are a student and you have access to this program, we can go to the student section, and it would look something like this if they were online, and then they have access to this glossary. This is all of the vocabulary that we use throughout this program in all those different sections, but in multiple language. So if you are in Pakistan, you might be using Urdu as your main language, right? So let's look at this whole book in Urdu. So you can see it here. And then we can open the book, whether it's earth and science or life sciences. And I don't know if we're connecting the sound of it, but we can try. And you can see here all of the words are there with an explanation. We can test. Can you hear it? I don't know if you can
No.
hear it. Probably because I didn't connect the sound, but you can have that there, and then you can click on this and it'll read out, and it's perfect pronunciation. And if you want, if you happen to be teaching in Arabic, you have the same book in Arabic, same thing. You click on it and you can actually hear the words in the explanation. If you happen to be in a place where you read, I don't know, French or Spanish or Vietnamese, you've got all of these options. So those are ways for you to really allow our students to make that connection between their language and the material that we're teaching. And again, what happens is that they'll be able to integrate as well English literacy and skills. So that's our program for our youngest. Now there are extensions all the way to grade 5, as you'll see here. If anytime you choose any one of those, and if you attend one of our sessions down the road, we're going to be offering sessions that is going to spend just an hour explaining this program. So we make that bridge between early elementary, kindergarten, grade 1, grade 2, to those grades 3 and up. So you've got that bridge here that allows it to take into consideration pedagogical approaches. So there's a lot we can say here about this, but this is a phenomenal program to start teaching our youngest about STEM. And research has shown, again, that if you were to compare students that only are taught reading versus students that have been taught reading and STEM in the same time, the students that are in the category of reading and STEM outperform by a lot all of the other students. And that is really interesting. It's as interesting as adding a second language for students early on. So that's this piece here. I hope I answered your question at length, but I hope I answered your question.
I did. I mean, you did, and because I've heard the sound, and I must say, for Urdu, it was like better than what I pronounced. To be very honest, really.
we
I mean, yeah, I've been
we
scolded
hired
on my
natives,
pronunciation,
we hired natives for all of it. Like it was
and
a
and
huge project.
And I think with the language integration module, no matter where you're in the world, it will not just make it accessible for those schools that have the affordability factor or who want to, like who are private schools or something. But if you're in a public-private partnership or your government school,
Yes.
like I know that there's a lot of reform going on in Pakistan. I think this would be a lovely thing to adopt, and it would be a lovely initiative.
Yes. And we will work with you. If you're in one of those schools and you say, well, there's no way we can afford it, trust me, we work with you. Our goal, if we could, our owners or our president's goal has always been, if I could, he said to me, I would give it all for free, but then I wouldn't be able to pay engineers and researchers and developers. So our programs are really not those crazy expensive programs that you hear about. They're just made in order to really support education and learning and STEM. And again, we're excited by the research that we have. We're excited by how it can change students' lives. And Frax, for example, I can tell you that after doing only 13 hours on Frax for a student, his life is changed. So if you have students that struggle with fractions, if you just adopt the grant, I can assure you that, and we're giving you the grant, like we're giving it for you. We're not asking anything other than your feedback and good usage so we can collect data. If you use Frax, it'll change the way they approach mathematics because there are flashpoints in math education. Fluency is a topic. Fractions is the next one in elementary. And if you've got those two areas covered, both fluency, automaticity, and fractions, you're ensuring that these students are going to be successful in mathematics and not only successful, but be able to approach learning math at the highest levels in the best way possible. And if you integrate gizmos into there, then you're really giving them the trifecta, and those students are all going to be extremely successful no matter what topic, or no matter what place in the world they are, and no matter what their initial abilities are. And that I think is important. An inclusive approach to teaching
Okay,
and learning.
Susan. I mean, I think it was a wonderful demo. Can we remove the share from
Yeah.
the screen so
Yes.
we can have you?
Yeah.
Yeah.
There you
Okay.
go.
All right. So as we move towards the end of our session, I mean, I feel that you have made and Explore Learning has made math, science, literacy integration so easy. I think at this point through this webinar, you have removed this fear teachers have of STEMifying their classrooms, of developing lesson plans, activities, differentiation. I mean, that is my thought when I'm looking at it. So,
Yes.
I mean, I think teachers should opt for it. And then on top of it, you're offering grants for them. You're offering free teacher access for 30 days. You're also offering global competition so teachers and students and schools can be highlighted at a global level, right?
Yes, absolutely. That's what we want. We want that, we know that some schools are always going to be top because, let's say, you're a school that has all of the resources and the teachers, you can compete anywhere and succeed. We want to facilitate that for everyone. If you can't get access to the programs, we'll give you the programs while you're competing for free, which means now it depends on you. We want to put the control back in your hand. And you can call us and we'll help you. We'll give you answer your questions. We'll support you. Those are important pieces. And when you think overall, game-based learning in education, when it's coupled with traditional instruction, like I said earlier, and proper teaching method, is really poised to revolutionize really education in the future. And technology, as we know it, is really at a breakneck space. When you think about it, AI, we haven't really worked with it 5 years ago. Last year, that was everything everyone could talk about. So we have to keep up with this. And we have to equip our students to really be successful no matter what happens in education and in technology. And I feel like these programs are really going to help. And if you're interested in AI, we'll talk. We should have a discussion around AI as well, AI in education. But gamification is definitely a big part of it. And having this approach that is both fun, as you can see here, it's not scary. You can try. You make a mistake. Guess what? You restart. You don't like the results. You restart. You have a wrong hypothesis. You restart. No cost, no equipment cost. It's very hard for some of these schools around the world to have the equipment to run these labs. Here, though, any of these labs are available to you. It's very hard sometimes to think about, oh my God, if I use all of my light bulbs in my circuit, then I won't be able to do the next class. You don't have to worry about that. You don't have to worry about chemicals. I know that there are many chemicals that are very dangerous or materials that are dangerous. But with simulations, you have access to those and the materials are basically free and you can reuse them as much as you want. So there's so many advantages to working through simulations that by using them and using the programs that we're offering, what you're doing is you're giving the best chance for your students to succeed. And we want to be part of it. We want to be helping you with that.
Okay, so I mean, I think what you just said about being able to do something over and over and over again and without actually harming or putting yourself or your students in harm's way,
Yes.
it is a critical, like a very important
Mm,
factor.
yes,
And reinforcement, we always know works for students, right?
of
And that's
course.
what simulations are helping us with.
My background is in astrophysics, and sometimes I wish I could do certain things that I wish I could do the things that we do in the simulation. Like, if I want to know the effect of a planet on, let's say, gravity, the gravity on a planet, what if I were to be able to, let's say, increase the gravity of a planet, remove the gravity from a planet, increase the size of a planet? I could never do that. No matter how much money I have, I could never do that. Right? So with the simulations, I can. And it's doing the impossible makes develops that ability for the students to develop their own creativity as well, because it puts them in situations that they couldn't do otherwise, right? So imagine if you could, for example, beam to the moon. How would you do it? Well, you can in gizmos. So this opportunity of opening the eyes and exciting those students and lighting that fire so that they want to always come back and research, understand concepts like what's the Big Bang, what happened, the creation of the universe, what's happening with the planets, what's happening underwater, why is agricultural waste not so good for some of these oceans, what's happening with the coral reef, how do I approach polynomials, or quadratics, all of this, no matter, it's like having those all of this knowledge at your fingertips, and you can control it, you can modify it, you can change it, and see what happens. It's exciting. I mean, every time I go and play with gizmos, I get excited. So,
I think it's time for teachers to turn into kids as well and enjoy the process of learning.
yes, yes, absolutely. We want you all to enjoy it. And we will, as I said, you can get access for free if you don't know how, if you haven't caught it through the little notes that my colleague has been putting out. I'm happy to reach out to me on LinkedIn, reach out to me wherever you may find me on YouTube. You can find me anywhere. We'll be happy to answer you. And we are very excited to see how we can help you.
Okay, so as we move towards the end of the session, um, I would just like to say please reach out to Suzanne, uh, reach out to Cynthia, and if you're not able to reach out to any of them, you can even reach out to me and I will help you connect with them. But I would say take advantage of these offers, these accounts, these rewards, webinars, free webinars, and STEMify your classroom. It's good for you, it's good for your students. And say, God forbid, there's another COVID situation, you'll be ready for
Oh,
that. Like, yeah.
definitely, definitely. And what we want to say to all of you, thank you so much. I really appreciate you taking time of your day and having this conversation with us. The world has been changing very fast, and sometimes it may seem that everything changes too much. Um, the anchor for us is learning. The more you learn, the easier it become. The more you look into these eyes that of all of these fantastic students that are all trying to, that are going to be the future of our world, the more you feel that you have a responsibility towards them to give them every opportunity to become problem solvers. We don't know what the future holds, but if we prepare our students, we know that they can face anything. That's why I'm really thankful for you, Jihad, to facilitating those presentations, these discussions, because your goals and our goals are aligned. We want to help build a better world and a more equitable world, a more inclusive world that allows anyone, no matter what their background and their history, to be successful and to realize their dreams. And we know at Explore Learning, we know for sure that anyone can be a mathematician and a scientist, just given the right tools and given the right opportunities.
Okay, Suzanne, so thank you so much for taking the time out so early in the morning. I know it's
Don't
very
worry,
early in the morning for
pleasure.
you.
It's my pleasure.
And I loved having this discussion. I mean, we have had those conversations a couple of times.
Yes,
And, but like, to be very honest, for everyone out there, Suzanne is one of the people, like, I think I can't wait to meet her again in person. And
me too.
Lisa
I will
was,
get with you.
so the next Tamina conference, Lisa, you and I need to sit together and grab a coffee. Yeah. And
Definitely. Well, we
then,
have a date in Dubai next time. You're in Dubai, and I happen to be there definitely. And we hope that some of you will start looking into coming to Stamina in November of this year. Really an amazing event, lots of ideas, and every year there's innovation. So but in the meantime, we hope that you'll participate in our competition, that you'll open your schools to having this opportunity to explore the world. And in science, one thing is for sure, that it's all about trial and error. So please have your students try. They're all they're going to do is they're going to learn, and learn more. They're gonna love you for it, and you're gonna see how exciting it's gonna be for them to build a project of some kind and see the beginning and to the end of a concept, right, that they come up with.
I definitely agree with Suzanne. And I would just like to say, please go like the Explore Learning pages, please. Connect with Suzanne or with Cynthia. And you can also connect with me. Um, I will be having one more session later in the month, which is based on AI and which is another like company that's doing like something very special using AI.
Mhm. Excellent. Well,
Okay.
thank you again. What a pleasure it's been. And I can't wait until next time.
Oh, you're definitely coming on next time as well. You'll have to take the time out.
There's a lot we would like to discuss more, and you're invited to, of course, to come to our webinars. We would love to have a session with you as well. So
Thank you.
next, you're a guest to our house.
Thank you so much, Suzanne. And I will end the session here at this on this note. And I really hope teachers, this was just for your benefit. It has nothing to do with me or nothing to do with Suzanne, except the common goal of enabling you as educators and in turn building a better future for education, which you know is the theme I'm very passionate about. Suzanne is very passionate about. Okay,
Yes.
so please connect with Cynthia, Suzanne, me, or anyone linked with Explore Learning for your free account, for grants if you want for your schools, for the STEM MENA award competitions, for the global competition. Everyone is accommodating you. Let's get together and let's improve the way we look at the world and improve the way our students can look at the world in a more sustainable, more durable manner. Okay, so take care. Good evening to those who are in this part of the region,
Yes.
and
Good
good
evening.
afternoon.
Great day. Thank
Have
you
a
so
good
much
day.
again. Thank you.
Okay, thank
Bye
you.
bye. Bye bye,
Bye bye.
everyone.